So last thing we're going to look at for this week is 6.5 part 2. It's really got three kind of parts to it. It's got the solving triangles, the connection I'm going to make with unit circle trig, and then the last part is some special patterns that we have with trig functions depending on the quadrant that you're in. There's patterns for all the trig functions, just for sine, just for tangent, and just for cosine. And I'll show you what those patterns are. So, if they ask you to solve a triangle, that means basically to find out all three sides and find all three angles. So there's 6 things. But we're working with right triangles. So what do you automatically know in every problem right away? There's a 90 degree. So out of 6 things, now we're down to 5. And even with that, I can't just draw a right triangle and say solve it. I got to give you a little bit more information. So I need to give you, in addition to having a 90, either the other acute angle and the length of one of the sides, and then have you find everything else. Or I can skip the angles and just give you 2 of the sides. Okay, but as long as I give you one of these situations, that's enough. How come giving you 2 angles wouldn't help? Yeah. Yeah. So if I told you I'm thinking of a triangle with angles of 45, 45, 90, how big are the sides? Could be anything. Because you don't have a side for a scale. So no matter which case I give you, you're always going to have one side, sometimes 2. Okay, keep in mind some things we can use here. Pythagorean Theorem. We can use that when we want to figure out a side. And we can use the fact that all the angles in a triangle add up to 180. So if you have 2 out of 3 angles, or I mean, if you even have 1 angle, then you have everything. Because you know you got a 90, and I'll give you one of the other ones. You can figure out the third one. So we'll practice each type. So everything that we're going to do today is going to involve sine, cosine, or tangent. The reason is because we need a calculator. Sine, cosine, and tangent are the trig functions you have buttons for on the calculator. Right. You can do this with secant, cosecant, and cotangent, but it's more work. So for each problem, you're going to have to pick one of those 3. The way you decide which one to use is you look at information they gave you and look at what you want to know and figure out the names of those sides. Like if they gave me the opposite and I'm trying to solve for hypotenuse, I'd say, okay, which function has opposite and hypotenuse in it? It would be sine. If they gave me the adjacent and I want to know the opposite and adjacent, okay, now I'm going to use tangent. So we just have to figure out which trig function to use based on the sides we know and the side we want to know. So let's look at an example. So it says one angle in a right triangle is 37 degrees and the hypotenuse has a length of 8 and the directions are to solve the triangle. All right, for most of these problems, it's going to be helpful if we represent that information in a different way. What's another way I could represent all this more concise? Different way, yeah?
Draw the triangle.
Yeah, let's draw it out. Now remember, anytime we draw something, it's not to scale. What's important is that we put things kind of across from each other that are supposed to go across from each other. So it says the hypotenuse is 8 and one of the angles is 37. So I want to give names to everything there that I don't know. What would be a name for one of the legs we could use?
A.
And how about the bottom side? B. Now, the angle that's across from A is always what?
Alpha.
Alpha. The one across from B? Beta. And the side across from the right angle is side what? C, the hypotenuse. So I'm going to write that information down. So I'm going to make a table. I'm going to put all three sides. I'm going to put all three angles. A, I don't know. So I'm going to put a box around it. B, I don't know. Put a box around it. C was the hypotenuse. So I know that's 8. Don't have to find that. Alpha, I know because I put it across from A. Now you might say, well, what if you switched A and B? That's fine. You're going to get the same answers I get for alpha and beta, except your answers are going to be switched. In this problem, they weren't specific about which one was which. Right? As long as you get the same answers, that's okay. So, one of the angles is 37. Beta, we don't know. Yeah, that's probably the first thing we could find pretty easily. Just subtract 37 from 90, and that'll tell you beta. Any questions why beta is 53? Okay. Now, when we go to solve for A and B, we have to use a side, and we have to use an angle. We have to pick one of each. We have a choice of two angles we could use when we solve for A or when we solve for B. We could use the 37, or we could use the 53. Which one do you think is better to use? Yep. I agree. 37 is a much better choice. How come?
Because in case you were wrong with beta, it won't stop.
Right. The way I'm going to show you how to do this, you're going to find everything separate. You're never going to use something that you found to find something else. Which means if you make a mistake on one thing, it's not going to mess up anything else. Right? So we found beta. Forget about it. We're not going to use it for anything. We're going to use the angle we were given and the side we were given. And now we have to find A or B. Doesn't matter which one. So Vinny, which one do you want to do first?
For the... What were you referring to?
For the sides. Which one do you want to find first?
Let's find
Side A. So I circled the two things that were given, and I circled the thing that I want to find. Now my next step is to figure out the trig function I need to use with this angle. Okay. What's the name of side A from the perspective of 37?
It is opposite.
That's opposite. So I'm looking for a trig function with opposite. And what's the name of the other side from the perspective? Hypotenuse. Out of sine, cosine, and tangent, which one is that?
Sine.
Sine. So, sine of 37 equals, and now fill it in, opposite over hypotenuse, A over 8. And how would I get A by itself there? Multiply by 8 times 8. We need to type that in, and we are going to round that off. Okay, today, they usually round the answers off when you're finding the side. What do I want to make sure of on my calculator first?
Your degrees.
Degrees. I think pretty much every problem's in degrees, but always check your problem first. And we're going to type in 8 sine 37. So we get a length of about 4.815. 4.815. Okay. Now, I've got 2 out of 3 sides in that triangle. What could I use now? I could. Why do you think I'm going to say it's not a good idea?
Because you'd be squaring like 4.85.
Okay, so we might get something that's inaccurate because we're using a value that's rounded. What else could happen? Yeah.
If that value is wrong, it will guarantee that B will be wrong too.
Yeah. If A is completely wrong and you use it, then now B is completely wrong. So we're not going to use A to find B. To find B, we're going to go back to the angle that was given, the side that was given, and now we're going to focus on that. So, we already know 8's the hypotenuse. What's side B? Adjacent. To find side B, we need a trig function that has adjacent and hypotenuse. Cosine. So this was to, I can just put directions here, this was to find A. Now we're going to find B. So cosine of, what's my angle? 37 equals what over what? B over 8. Same, pretty much the same step as last time. Multiply by 8 times 8. And it's 8 cosine 37. Right, so we get 6.389. Now, a couple things I can do to check and see if my answers are pretty good. A couple of them are quick, some of them not so quick. You should always have the biggest side across from the biggest angle. The smallest side should be with the smallest angle. That's very, very quick to check. If that doesn't happen, something's wrong. The other thing that you can check, this takes a little longer, but any two sides added together have to be bigger than the third. That's true in any triangle. If you add 4 and 6, that's bigger than 8. 4 and 8 is bigger than 6. 6 plus 8 is bigger than 4. So that's good. Any two sides added together have to be bigger than the third. And the last thing you could check is you could plug that into Pythagorean Theorem. A squared plus B squared should come out to what number? Should be 64. 4.815 squared plus 6.389 squared should be 64. I got 64.004. So is something wrong? No, it's just because I rounded. But because a squared plus b squared did equal c squared, and everything else I checked, that confirms we probably did it right. Questions on that? All right, let's try this one. So this is just from, I guess, example 2 in your notes. Okay, so what's first thing I should do here? Yeah, make a diagram and we'll make a table. Let's put A across from alpha, B from beta, C across from the 90. All right. The table, if you want to make that, it's up to you. It's just to kind of organize all the information. Alpha, we got that. Beta, we don't. And that, we always have. Okay, what could I find first? Yep.
Okay, we could start with beta equals 70 degrees.
Yeah, I mean, you can start with anything, but beta is the quickest, I think, because you just add up everything and make sure it adds up to 180.
Yeah.
Now, are we going to use beta for anything else?
I would use it as our starting point.
What do you mean?
What was it?
Are we going to use beta to find B or to find C? I would use alpha. How come?
Because we was given.
It's given. I know this is right. I want a different color. I know this is right. I know that's right. At least if I stick with the information that was given, I can make a mistake on one part and it won't mess up anything else. So B or C, which one you want to do next? A, I know. I just forgot to write it. Sorry. Which one? B. So figure out the names of these two sides from the perspective of the 20. Opposite and adjacent. Which trig function?
Cotangent. I
Um,
would use wait. Yeah, I would use
We could
cotangent.
use tangent, but cotangent's in a valuable
It would be A over O. So B would be on top, and then
We could just multiply 12.3 and go.
so you could, the only thing is you just don't have a button for that on the calculator.
yeah.
You don't have a COT, so you're going to have to end up flipping something else if you use cotangent. So if you use tangent, tangent of your angle equals, now the variable is going to end up in the bottom. We haven't had that happen yet. The number is in the top, the variable is in the bottom. So I'm going to show you a trick for what happens, and then we're just going to use this trick in the future. First thing you want to do is just get rid of the fraction. So how would you get rid of your fraction? Multiply both sides by b. That would give you this. b tangent 20 equals 12.3. And now what would you do?
Divide by tangent 20 degrees.
Divide by tangent 20. Now, look at what we ended up with and look at what we started with. Yeah, all you have to do is take these two things and switch them. The reason why we just went through. But that happens in any fraction. If you had the fraction x equals a over b, you can say b equals a over x. You can always switch the denominator with what's on the other side by itself. Okay. So let's see what that comes out to. 12.3 divided by tangent 20 gives you 33.794, and that was for B. Now, before I find C, can anybody tell me anything about it? I'm thinking of something numeric about it. You don't know exactly what it is, but you've got enough information there to say something about it. Yeah?
It has to be more than 46.
Well, yeah, it's definitely got to be more than 33 because it's the biggest side. But it can't be more. It can't be more than 46 because these two added together have to be bigger. So if it came out to like 50, that's a problem. So it's got to be less than, roughly less than 46, but it's got to be more than 33. So let's see if that's what happens. All right. So again, we're going to focus on. We're going to focus on 12.3, 20, and this time I want to look at the C. So. What trig function am I going to use to find C? Sine. Opposite. Hypotenuse. So this was to find B. Now we will find C. So sine of, what's my angle? 20. Equals, what goes on the top? Divided by C. And what can I do to get C by itself? Yeah, I mean, you can multiply and then divide, or you can just switch it. C equals 12.3 over sine 20. And it should be between those two numbers I just said. Does anybody have what it comes out to? 35.963. 962. Okay. And that's it. Any questions on that type? Yeah.
Do you want them all rounded out 3 places?
I just pick 3. I usually go 3 because of something we're going to do in chapter 7 or 8. Yeah, so we'll stick with 3. So technically the first one is not 3 because they gave me that one. We could assume that it's really that. Okay, so questions on the type where they give you an angle and a side. Okay, let's try the type where you are given 2 sides. All right, so it says I guess technically this is example 3 in your notes. The hypotenuse and one of the legs in a triangle is 12.7 and 6.1. Now, they don't say which one is which, but if you're given two numbers and when they say one of them is the hypotenuse, how do you know which one the hypotenuse is? It's got to be the bigger one. So the hypotenuse is 12.7 and the leg is 6.1. Okay, let's draw that out. All right, so we'll put 12.7 here. We'll put 6.1 here. And we'll call that side A. What's this angle up at the top going to be? Angle on the right at the bottom? Beta. Let's make a chart of everything we've got. A, we don't know. What's B? Because that's across from beta. And C, because that's the hypotenuse. All right. Do we know alpha? Nope. Do we know beta? Nope. And that's a 90. Okay. So, what could we use this time that I would be okay with you using? Why? Why am I okay with? Because you were given two sides. So Pythagorean theorem here is okay to use. You're not using something you calculated. Pat, can you set up for me what that'll look like?
You want to put like an a squared and then put 6.1 plus 6.1 squared equals 12.7 squared.
Yep. And let's just get a by itself before we do any arithmetic out. What would be your first step here to get a by itself?
Subtract these.
Just subtract the 6.1 squared. And last step.
Square both of them.
Before that. How do I get from that to that? Square root. So take the square root of 12.7 squared minus 6.1 squared. If you type it in that way, you're not rounding anything off until the end. If you square 12.7 and round it, and then square 6.1 and round it, and then subtract it and round it, and then take the square root and round it, you've now rounded 4 times in the same problem. That's a lot of rounding. So if you can, try to do it like that. And this is how you type it in. 12.7 squared minus 6.1 squared. Okay. So we get A is 11.139. Questions on that? All right, so now we have to find alpha and beta. So we're definitely going to use that, and we definitely want to use that. And we can pick which angle we want to find. Let's do alpha first. Which trig function would I use to find alpha?
Adjacent.
It's adjacent and hypotenuse, yeah, which is cosine. All right, so this was to find A. Now we're going to find alpha. So it's going to be cosine of what? Alpha equals what over what? 6.1 over 12.7. What's a little different about that? It's not like the last two.
Yeah.
Yeah, what we have to do here is the variable is not part of the fraction on the right, it's inside the trig function. Right? That's like having something like this. You've got a variable inside another function. So the only way to get rid of that function would be to square both sides, and you get x equals 144. Well, the only way to get rid of this function is to do something that means the opposite of cosine. So I would say just leave maybe 3 or 4 steps there to finish that up. But that's where we're at right now. Or however you want to do it. So the way we have to cancel out cosine is with what's called inverse trig. So inverse trig, if you've looked at those buttons that have like a little -1 above them, that's inverse trig. So sine with a -1 means inverse sine. This means inverse cosine. This means inverse tangent. What I have in parentheses, that means the same thing. Okay. Arc sine, arc cosine, and arc tangent also mean inverse. The way on the left, it's kind of a more modern way of doing it. You don't see it on the right as much, but there might be some pre-cal or calculus books that refer to like taking the arc sine of both sides, and it means inverse sine. Now, what's a little confusing about this notation is this number. That number is a little higher than the word sine. Usually when you put a number higher, it's a what? It's an exponent. That's not an exponent. That -1 is just a symbol that means inverse. Now, to make it even more confusing, if you put a 2 there, that is an exponent. That, like sine squared x, really means this. That's the same thing. Nobody writes sine squared, though, the way I showed you on the right. They write it on the left. So the point there is if you have a number higher than a trig function, and it's any number except a -1, then that number is an exponent. If it's a -1, that's just a very special case, meaning inverse. Just the way it is. So any questions on that notation? All right, so let's finish this one up. So to get cosine by itself, what trig function do we have to use? Inverse cosine. Now, I'm kind of picky about how you say it. So like, if you had this, you'd say, you square both sides. Or if you had something like, let's say the opposite of that. Let's say that. How would you explain how to solve the bottom one? Take. Right? So the first word she said, take the square root of both sides. You don't multiply both sides by the square root. You don't divide both sides by square root. That doesn't make sense. You can't add, subtract, multiply, or divide with a function. Add, subtract, multiply, and divide is for numbers and letters. So the way we would say this one is take the inverse cosine of everything on the left, and there's no multiplication happening there. Just like there is no multiplication happening if I did something like this. Yeah, there's parentheses there, but the parentheses don't mean multiplication in this case. Right? They don't. Same thing here. The parentheses are just there to define the argument to the inverse cosine function. And the argument is the cosine function. And when you plug cosine into inverse cosine, it's like plugging square into square root. Cancels out. And I don't really have enough room, but I'm just going to squeeze it in over here. Take the inverse cosine of that. Okay, now we type inverse cosine of 6.1 over 12.7. Okay, on your calculator, you press second and then cosine. That's how you do inverse. You have to press second. 6.1 divided by 12.7. 61.294. Now, what did I just find? I found alpha. So, alpha is a what in this problem? It's an angle. So, what is this 61.294 what? Degrees. anytime you do inverse trig, your answer has to have a label. It's either radians or degrees. Okay, one of those two. So inverse trig is always used when you want to find an angle. That's what it's used for. You don't have to use inverse trig in case 1 at all, ever. Because in case 1, you're never going to have to solve for an angle. You can just add up and subtract from 180. Case 2 is where you have to use inverse trig. Always. All right, so what do we have? That's not. Okay, so we've got ABC, we've got alpha, we've got beta. I know we need to find beta. So let's finish up with that. Now, if you were running out of time and you only had 15 seconds left and then the bell was going to ring, you could do 90 minus 61.294. Right? And if you do that, 90 minus 61.294, you get 28.706, and you're hoping you didn't make a mistake with alpha. Keep that number in mind, 28.706. We're going to find beta, same way we found alpha. Okay, we're going to use inverse trig. So here's beta. What trig function would you use to find beta? Sine, opposite over hypotenuse. So sine of beta equals, what goes on the other side? 6.1 over 12.7. Now you have a function you need to cancel out. What's the function that cancels it out? Inverse sine. So we are going to take inverse sine of each side. And you're going to get this. I don't remember what the number I had was. 28.706?
Yeah.
Is that what it comes out to? Okay, so if you take the inverse sine of that, you do get 28.706. And if you can get the same answer 2 different ways, then it means it's pretty sure it's right. 28.706. So any questions on the type where they give you 2 sides? Okay. So with that, that's the same thing, 2 sides again. All right. So I want to look at the connection here between this and unit circle trig. So what I've done here is I've drawn a unit circle. That's the part in the middle. So this part, let's see if this still works. So that part is basically what we did before. All we did was focus on the unit circle. Well, we can think beyond the unit circle. Right? When we do unit circle trig, it's really the same idea you can use with any size circle. Doesn't matter what radius you want to use. Because, tie this in with something I said earlier. Look at that triangle in green. Ignore these random. Oh, okay. So let's move that. I just want to move it to a different spot. If I can. We get that triangle in green. Now look at this triangle in red. How do those 2 triangles compare?
They're similar.
They're similar, right? They're similar triangles. And what do we know about trig functions of similar triangles? They're the same. So whether you do trigonometry on a circle with a radius of 1 or a circle of radius r, it doesn't matter. Now, in the problem with a unit circle, the hypotenuse is 1, this is x, this is y. So let's put that right here. Okay, so this was unit circle. This is going to be circle with radius r. So that becomes r. All we have to do to be able to do this on a bigger circle, which is really just a similar triangle, is take our bigger triangle and scale it back down to a unit circle. If we can take the red triangle and scale it back down, we already know how to do it. So, think about, you've got a radius of, let's make up an actual number. Let's say your radius is 5. What would you have to scale a triangle that had a radius of 5 by to make it back a radius of 1? 1/5. What if your radius was 6? Scale it by 1/6. What if your radius is r?
1 over r.
1 over r. So if you take a triangle that's on a bigger circle and you scale everything by 1 over r. Yeah, it'd be y over r, sorry. That's what your sides would turn into. X would turn into x over r. Y would turn into y over r if you scaled it back down. So if you write that down, x would turn into x over r once you scale it. Y turns into y over r if you scale it. If you make those two substitutions in the formulas I've already given you for unit circle trig, everything works. So, originally, on the unit circle, sine was which letter? Y. Sine was y. Cosine? X in tangent. Cosecant? 1 over y. Secant? 1 over x. X over y. Those are the definitions on a unit circle. Okay, we did that a couple weeks ago. Now, we already did that. So we figured out, okay, if you're on a circle that is bigger than 1, let's say it's a circle of radius r, just take all your numbers and scale them back down in such a way that you would force this hypotenuse to be 1 again. And then you've shrunk your triangle down, which is okay because similar triangles have the same trig functions. We're just changing it back to a smaller problem. So you'd have to scale everything by r. So, sine was y, but y is going to turn into y over r. Cosine was x, but what does x turn into?
X over r.
And tangent was what? It was y over x, but y turns into y over r. X turns into x over r. It's the same thing. The r's cancel out, and tangent stays exactly the same. I think I write this, yeah, right here. So you just wrote that. Sine is y over r. Cosine is x over r. Tangent, y over x. So what do you think the cosecant would be? Secant? And cotangent, x over y. So the formulas that I gave you when we did unit circle trig were really these formulas. The only thing I did is I let r equal 1 to make the numbers simple. Y over 1, x over 1, y over x. 1 over y, 1 over x, x over y. So change all the r's to 1s. And now you've got your unit circle back. But now r might not be 1. Okay? So when you do a problem, you're going to be given the x, you're going to be given the y. But there's one more thing you have to find out. You have to figure out how big of a circle you have. That's your radius. So, Here's a point 2 comma 3. The point 2 comma 3 is not on the unit circle. Points on the unit circle usually have 1/2, square root 3 over 2, square root 2 over 2, 0 comma 1, 1 comma 0, things like that. 2 comma 3, it's way off the unit circle. If you're not sure, sketch a unit circle. 1 unit in every direction. Sketch the point 2, 3. It's way up there. It's not on the unit circle. What we have to figure out is how big of a circle is it on. That's your radius. How would you find your radius of that circle? Yeah, just use the Pythagorean theorem. Make a triangle. That side's 2, that side's 3. So in this case, r would be the square root of 9 plus 4, which is 13. That's the only extra step to doing trig not on the unit circle. Pythagorean theorem gives you your radius, and now you just fill everything in. Okay, so what's my sign?
3 over the square root of 13, so...
Yep. And that's kind of annoying, but that happens a lot. How about my cosine?
13 over 13.
X over r. And my tangent?
3 divided by
3 divided by 2. Hey, how about my cosecant?
square root of 13 divided by 3.
Yep, just flip that. My secant? Over 2. And my cotangent? 2/3. So now you have a way to find the trig functions for an angle represented by a coordinate on any circle anywhere. And all you really did, if you think of it like this, you put theta right here, you use Pythagorean theorem, you really did this problem just like a triangle. Okay? Opposite over hypotenuse is your sine. Adjacent over hypotenuse is your cosine. So doing this on a unit circle, doing it on a right triangle is the same thing. Exactly the same thing. Okay. Any questions on that? All right. So now, let's figure out how big that angle is. Any one of these 6 things right here is enough information for me to figure out the size of that angle. Let's use this one. Sine theta equals 3 over the square root of 13. Doesn't matter which one you use. I use 3 over square root of 13 because it was less writing. And that's not a final answer to a problem anyway. This is going to be my final answer. How would I get theta by itself? Take the inverse sine. Theta equals the inverse sine of that. So let's see how big that angle is. Based on my picture, it should be less than 1 because it's in quadrant 1. It's got to be less than 90. Can't be more than 90. So inverse sine 3 divided by square root of 13. Technically, I don't think you have to close your parenthesis. It'll probably be fine if you don't. I usually do. 56, that's going to round up to 3/1. Okay, there's your angle, 56.31 degrees. Now, this is where I'm going to start to tie in this diagram. So this is the last thing. That coordinate, 2, 3, had to be in the first 12. So I knew that the angle was less than 90. Now, if you had a point in the second, third, or fourth quadrants, that could be a little tricky because Let's look at this one, for example. So let's say you had a triangle that went that way. Let's do the same problem. -2, 3. Now, this is the angle that I want to know. From there to there. That's what you're looking for. Let's try what we just did. Forgot, what was the hypotenuse again? Square root of 13?
Yes.
Okay. So, sine of theta equals opposite over hypotenuse. It's the same equation. And when you solve, you're going to get the same angle for theta, 56.31. But that's that angle right there. We got to be careful because 56.31 is not an answer in quadrant 2. So we can do something with that, add or subtract it to something. But you have to know that you're in the second quadrant. You subtract it from 180. So I'm going to give you a formula for what you do in each quadrant. In quadrant 2, you subtract it from 180. What if your angle was down here? What do you think you would do to find that? Well, you would know this. You would add it to 180, because 180 would bring you halfway, and then that angle is going to bring you that much more. So you either are going to have to subtract from 180, add to 180, or what if your angle was in quadrant 4? How would you find that?
Add 270.
You could subtract it from 360, right? Because you're this much shy of going all the way around. You could do something with 270 if you knew this, but you'll never know that. Okay? So I'll show you the different formulas. So what you're finding right here in quadrant 2, that's called your reference angle. In general, no matter what quadrant you're in, if you make a triangle, where I'm putting theta, that is called a reference angle. It's not the actual answer, it's part of the answer. The actual answer is one of those three. If you're in quadrant 2, it's 180 minus your reference angle. That'll get you to right there. If you're in quadrant 3, it's 180 plus your reference angle. And if you're in quadrant 4, it's 360 minus. Another thing is your reference angle is always positive. Reference angles are never negative. So that's why I say take the absolute value of the inverse sine. That's the easiest way to find a reference angle. Another reason inverse sine is easy is because if you have a coordinate, inverse sine can be found. All you got to do is use Pythagorean Theorem to get your hypotenuse. Okay, and then you'll have opposite over hypotenuse. It's a little tricky at first. We're going to do this a lot for the next few chapters. So let's look at an example. So, is that the one? No, that's a little different. So you're given the point 2, -3, and they tell you that that is on the terminal side of your angle. Okay, so I don't need a grid, but I'll show it to you the first time. Where's 2, -3?
Fourth quadrant.
Fourth quadrant. 2, -3. There's your initial side in standard position. Here's your terminal side. Find theta. What they mean by theta is that. So what you're going to find first is your reference angle. So I want to make that bigger. Let's make a triangle out of it. The height of that triangle is how long? 3. The base? 2. It's the same triangle we've done, just flipped into a different quadrant. What's the hypotenuse? square root of 13. Here's your reference angle. Right there. Okay. So let's call that theta sub r. That's my reference angle. Let's call this whole thing theta. So let's find the reference angle. What trig function did I say to always use for the reference angle? Sine. So sine, you know what, it's going to be easier if I do it like this probably first. The sine of my reference angle equals what over what?
3 over square.
Yep, same thing we've done. And now, I jump to this right away because that's how I would probably do it. I wouldn't even write the first step. What's the formula for my reference angle?
Inverse sine.
Yep. And we already know what that comes out to. What does that come out to? 56.31. That's my reference angle. So I'm in quadrant 4. What should I do with 56.31? Subtract it from 360, and that's the angle that they want. 360 minus 56.31. 303.69. So they may ask you for the reference angle, and then they may ask you for the whole angle. In this case, they just wanted the whole angle. Any question on that? All right, and is this the last? Yeah, last thing. Remember for your quadrantal angles, those angles are special cases because they're on a quadrant. When you write the coordinate for a quadrantal angle, the coordinate is on an axis. So it always has what number in it? Always has a 0. 0. 0 comma something or something comma 0. So that means if you find any of the 6 trig functions for those 4 angles, it'll always be one of those answers. 1, 0, -1, or undefined. All right. So the last thing is this diagram. And this diagram basically shows you where certain trig functions always come out positive or negative. Now, I don't think we do a ton with it in this section, but it comes up for a long time in the next couple chapters. In quadrant 1, all of the trig functions come out positive. So, if you gave me any angle between 0 and 90 degrees, I could tell you right away that the sine, the cosine, and the tangent of those angles would all be positive. If you gave me an angle in quadrant 2, somewhere between 90 and 180, I could tell you that cosine of it always be negative. Okay? We can try it. Pick any number between 90 and 180.
$172.
172. Cosine is negative. Okay, it comes out negative. If you get an angle somewhere between 180 and 270, the only thing that will come out positive is your tangent. The sine would be negative, the cosine would be negative. And if you pick an angle between 270 and 360, the cosine would come out positive. And I've never written it like that and showed you, but you kind of could figure that out if you know this. Sine is y, cosine is x, tangent is y over x. Think about y for a second. Y is sine. Where is y positive? Which 2 quadrants? 1 and 2. Those are the two places where sine is positive. What quadrants have a positive x value? 1 and 4. That's why cosine is positive there. Now, tangent is y divided by x. There's two ways you can get a positive when you divide. What's one way you can divide and get a positive number?
Positive divided by positive.
Positive divided by a positive. Where are x and y both positive? That's why tangent is positive in quadrant 1. Or what else can you divide and get a positive? A negative over a negative. Where are x and y both negative? Quadrant 3. So this information was kind of already in your head in a different way. This just makes it, I think, easier to think about. So you don't have to think about y, x, and y over x. Okay. Any questions on that diagram? All right. So, homework for tonight. Okay, so take home, which is part 1 of the test. Okay, so this will be due at 10, what time we have class? Oh, we have 10 go on. So we have class tomorrow, 3rd period. Yes? You can check if you want, I'm not sure. See if you left the gym bag. No? If I see it, I'll let you know. You're welcome. So let's see, period 1 is 7:51, period 2 is 8:30, so it's like 9:15. So this is due at 9:20 a.m. on 12/13. If you are absent, then you have to make sure to get part 1 to me by 9:20 a.m. or it will be a 0. If late equals the cosine of 90. What else? Make sure you give the test directly to me. That shouldn't be an issue because you're bringing it to class. Don't drop it off. Don't leave it with anybody else. Is there anybody that thinks, you know what, I'm going away. I know I'm not going to be here, and I don't have access to email to get it to you by 9:20, if you're not here. So everybody that's here today can get it to me, if they had to, by 9:20, if they're absent. Okay, perfect.